Okay, we have the following setup here. We have a right cone with a radius of 15 or diameter 30. It's situated on the ground, or we can call it the horizontal projection plane. It's resting on it. And we are slicing it with a projecting plane, which in this case is also a level plane, meaning it's parallel to the X line. To show it to you in 3D, that's what it looks like. And we do not have the projection of this plane in the frontal projection, obviously, because we would not be able to see anything. They coincide with one another, so we do not get the other projection for alpha. I have for some reason called it O1, sorry. It should be A1 or Alpha 1. Just pretend this is the Greek alphabet. Sorry, I do not have it right now. And let's just roll with that. All we can do now is to find the intersection here, and since it is perpendicular to the base, it's going to give us hyperbole. Um, it's not so difficult to find these points, but there is one particular point for which I'm recording this guide. Um, as you can see, we have to find some of the extreme points. One of them is this one of them is this one, and the highest point of the intersection. And then we need the directional point, uh, which we will use to construct the hyperbole itself. You don't have to find a pair of 2 points here and there. If you have one side found, you can see it. Since it is a level plane parallel to the frontal projection plane, you are going to get nice intersection which is symmetrical. If you pay attention, it's exactly symmetrical because hyperbole is obviously a symmetrical object. And yeah, if we find this one, we can just mirror it with the center of the axis, and that's it. But we need to get started. Uh, Obviously, I cannot see any points here, but I see all the intersection points here. Even though they all align on this simple part, it's not that simple apparently, because if I look at it from the top, you see that intersection, that hyperbole becomes a single straight line. So it's all matter of perspective. Um, so let's get started. We need to mark some points. Maybe let's start by having the extreme points, this one, and obviously the highest point will be here. Okay, I'm going to leave this point for now and get back to it later, but let's get started because that's the tricky point which I was talking about. We can name the points to get things started, and I'm going to call this 3, 1, but as I said, I'm going to stay away from it for now. I want to get started by these two extreme points. Let's draw the connection lines. Let me borrow this line here. So let's draw the connection lines. Obviously, if we look at it in 3D, obviously, like imagining an object you are working on in 3D helps a lot. Here is a point I'm talking about, and I can already see that this point is located on the base. I do not need to attach it to anything else because base is already defined in both of the views. Here is the base seen as the circle, and here is the base seen as the single line. So I have enough information to find these 2 points. That's 1 and that's 2 right here. We can also give them their respective names here and here. Let's call them what they were called down there. This will be 1, 2, and this one will be 2, 2. And you may be wondering, why do I have point A here? Normally, when you are drawing the cone and you are given the coordinates, you are given the height, coordinates for S, you're given the coordinates of the center on the base, and you're given one of the extreme generator points, which in this case was A. So yeah, if you have O and A, you will simply scribe or draw the entire circle. So we have 2 points. We need a couple more because we need the directional points, but again, we need to find 3. But before we get to 3, I want to find a couple of directional points. Let's get started on some random point. This is not for convenience, we are doing it purely randomly. So let's mark this point, give it a name. I don't know, maybe we can call it 4-1, doesn't really matter. And we need to attach it somehow. It's in the space this time. So if we look at it in the 3D, maybe we're talking about this point here. I do not really know, but if I'm eyeballing it, I would guess it's somewhere here. So it's not no longer on the base or any other convenient line, so we have to create that line. We also know that the cone is made up of generators. So if I were to draw that generator, I'm going to try that, but I'm not promising anything. So if I start from the apex and if I join it to the center, so yeah, that's the generator I'm talking about. And if it was the point 4, as you can see, it's on the generator itself, and it's also connected to the hyperbole. It's the part of it. So now let's get back to the drawing and try to replicate it on the 2D paper, because it's obviously much easier in 3D. So how do we replicate that thing? So I'm going to use a different color this time. I'm going to maybe pink. From the apex point, we draw a generator or a line going through this point, which I'm trying to locate. And I attach this to the base, obviously, and then I have to mark this. Let's call it 4-1 dashed, like this. And why I did this? It's because point 4 dash is responsible for point 4. So it's easier to keep track of. Now let's find point 4 just the way we did for point 1. It should be resting on the base here. So let me just move this slightly. Okay, or it doesn't really matter. I'm going to move it down here, even though I don't like doing that. But in this case, I'm going to roll with it. Let's call this point a name as well. Like this, and let's draw the generator. Well, first, let's change the name for it, for dash, or for prime, not dash, sorry. And now let's join it with the same color. I think it was this one. Since the generator was defined by the 4 prime and S apex, we simply draw this, and I know that this point is located somewhere alongside this generator, and I also can draw the connection line from here, because it has to be on this vertical connection line, obviously, and wherever it intersects, I overwent it, but you don't have to. That's the point I'm looking for. Let's mark it, call it a name as well, and that's one of the points. So I think you get the idea of it. Now, how do we mirror this part on the other side? In computer, I can simply press the command and get the point like this, but on paper that simply doesn't work, obviously. If I have a compass with me, what I can do is put it in here, measure out to 4 prime, rotate it, and find the intersection here. Obviously, I do not have to draw the entire arc, only this part, this intersection part was enough. So once I have that part, what I'm going to do is also draw the generator like this, and while mirroring, this one is not going to lose any height, so obviously it's simply going to be transferred across. And we can call it a name as well, or you don't have to, you just know this is one of the points. Next, we can do as many points as we like alongside this. I'm going to do one more later, well, let's just do it now. It's not that long of a process. So we have this point there, let's call it a name. Let's give it 5-1. And procedure is the same. We need to draw, maybe let's give it a different color now. I'm going to give it green so we know which generator is responsible for which one. So here it is. Let's also give it a name, 5 prime. Let's draw the respective points. Here it is. And yeah, let's complete the generator. And 5 should be on the vertical connection line, or both of the projections will be connected, obviously. So here it will be. Let's mark it, give it a name, 5-2. And also let's find it should be somewhere alongside this line, but we need to find generator. I'm going to like make it worse for me and do the same way you would do. So yeah, you can bear with me here. Like this, and that's the intersection I was looking for. And yeah, we are done here. Let's move on to the point I was trying to avoid, which was this one right here, point 3. Okay, let's imagine that this line is a generator, right? Okay, we have to find the generator. Let's just imitate what I'm saying. Let's take a red line, draw it here. Okay, fair enough. Let's find this point. It's on base. It's right here. If I join it to the apex, well, cool. Problem is that generator is also the same line that would be the connection line for 3. Obviously, that doesn't work for me. That's because line which I drew, or the generator, is the profile line, which means it's parallel to the profile projection plane. And for that matter, I have to construct the entire profile projection view, or the side view, just to find that one point. But I can use the clever trick and get around it. Normally, you would do, as I said, you would construct the entire profile projection view and then find the point like that. And then you would transfer the height, because I cannot really define height here, but there are another views which I can see the height. So let's just try to get around it. There is one way of doing it. Mind you, there are multiple ways of avoiding it, but I'm going to use this one for now. If I put the compass here, measure out to 0.3 and rotate it like this. So I'm kind of drawing the mini version of that projection of the profile. So let's call it 3. I'm going to give it drop, but not like this. Let's draw like this. So now let's ask ourselves, after the rotation, okay, if I rotate the pencil in my head, it doesn't drop any height, it doesn't change anything. If there are numbers written on it, it's going to remain at the same height no matter the orientation. That's the same thing here. If I rotated 0.3 alongside the rotation axis of the cone. So it got rotated, and instead of being on a profile plane or profile line, it's now on the level line, which is frontal, and it's also happened to be the extreme generator, which is this one right here. I'm going to select it. Yeah, this red line is the profile, nor the extreme generator in the frontal projection view. So let's find its projection on that extreme generator. It's right here. Let's mark the point right here, and let's also give it a name, just so we can keep track of it, like so. And let's simply take it back, because the rotation means it's it's going on this direction. It's rotating on its level. It's not going to drop any height. So let's just take it back. It should be, oh, sorry, it should be somewhere here. That's the trajectory it's going, but I am only concerned about this part. So that's where it is, and let's call it a name, which will be 3, 2. So let's give it a contour, starting from point 1 and going through all the directional points, and then it's going to reach the turning point, which will be point 3, the highest or one of the extreme points. Then yeah, we have to go back, and it's going to be exactly the symmetric, like this. So that's the cut part I was looking for. You can dash it or give it a shade, it's fine. And in the projection of the side view, let's just see how it would look. It looks like a single line. And I would have this drawn. Let's erase this generator, we don't really need it. So we would simply take this point back, but as I said, we drew the mini version of it, like this one. So that's the task I was going to focus in this short video, and if you have any questions, you can ask me, that's fine. And yeah, I'll try to um, think of the better topic for the next one and record the guide for that too. So stay tuned for that.